Welcome back, everyone. We are up to lessons 21 and 22 of Unit 2, and these two lessons are about what we call rational equations. Rational equations are just simply equations that involve rational functions. Rational functions has been the focus of the second half of this unit. So we're going to solve equations involving rational functions. And to solve these, we're going to use the cross-multiplying trick that you've used before in earlier math courses. So we're going to cross multiply and we're going to solve the resulting equations for x. Something to note here is that it could end up that you may have to solve a quadratic. The resulting equation could end up being a quadratic. It might happen, it might not. If it does happen, then you have to solve by factoring or by using the quadratic formula. So with that in mind, let's go right to our examples here. So let's take a look at number 1, which I have written out already. Again, like I said, to solve this, we are going to cross multiply. Okay. And when I cross multiply, in this case, for example, on this diagonal, I'm not just going to multiply the 12 times the 6. I'm also going to multiply the 12 times the minus x. Similarly, on this diagonal, I'm not just going to multiply the 4 times the 6. I'm also going to multiply the 4 times the x. So on this diagonal, 4 times 6 is 24, and 4 times x is 4x. So that's the one diagonal. On the other diagonal, 12 times 6 is 72, and 12 times negative x, that's going to be a minus 12x. You can see here that this is not going to be a quadratic. It's just a regular linear equation that we can solve like we normally do. So remember, when we solve linear equations, we want to move all of the variables over to one side of the equal sign, and we want to move all the constants to the other side of the equal sign. So in an effort to keep things positive, I'm going to choose to move the minus 12x over by adding 12x to both sides. So in other words, I'm going to move the variables to the left-hand side, which means all of the constants are going to get moved over to the right-hand side. So the 24 is going to get moved over to the right-hand side by subtraction. Okay, so negative 12x and positive 12x cancel. 24 and negative 24 cancel. When we put everything together, I end up with 4x plus 12x, which is 16x. And 72 minus 24, that's going to be 48. So I have 16x equals 48. And if I divide by 16, all right, x equals 48 divided by 16, which is 3. So for number 1, there is only one solution, x equals 3. Okay, let's go to number 2. Let's write out number 2. We have x plus 3 over 3 equals 8 over x minus 2. And what makes this one different is that when I multiply along this diagonal, when I cross multiply here, I'm going to have to use the box method. Okay, I'm going to have to use the box method in order to multiply x plus 3 times x minus 2. The other diagonal is easy because this is just 8 times 3. So this one is just 8 times 3, which is 24. But the other diagonal, I'm going to have to quickly set up the box method. So let's do that. So x plus 3 and x minus 2. So let's see what we end up getting. So x times x is going to be x squared. 3 times x is going to be 3x. Negative 2 times x is going to be negative 2x. And negative 2 times 3 is going to be negative 6. So if I put that together, I end up with x squared. 3x and negative 2x becomes a positive 1x. minus 6. So x squared plus 1x minus 6 equals 24. So you can see here, this is going to be a quadratic, which means I need to rewrite this so that it's set equal to 0. So in order to do that, I'm going to have to subtract 24 from both sides in order to make that happen. So 24 minus 24 is 0. On the left-hand side, I'm going to end up with x squared plus 1x, okay, and then negative 6 minus 24. Negative 6 minus 24 is going to be negative 30, right? I'm just going to double check real quick with a calculator. Negative 6 minus 24 is indeed negative 30. Okay, and now I can either use the quadratic formula or I'm going to factor. I always find it easier to try to factor first, and if I can't factor, then you could use the quadratic formula. So remember, when we're factoring, we want to look for two numbers. In this case, we want two numbers that when I add those two numbers, I get 1. And when I multiply those same two numbers, I get negative 30. So again, I'm looking for two numbers that when I add them, I get positive 1. When I multiply those same two numbers, I get negative 30. So in this case, that's going to end up being 6 and negative 5. All right, if you're not sure, let's check. Is 6 plus negative 5 equal to 1? Yes. Is 6 times negative 5 equal to negative 30? Yes. So when I factor, I end up with x plus 6, x minus 5 equals 0. I can now set each factor equal to 0 and solve for x. So in the first factor, x plus 6 equals 0. All right, if I subtract 6 from both sides, I'm going to end up with x equals negative 6. And on the right-hand side, if I add 5 to both sides, I'm going to end up with x equals 5. So number 2 actually has two solutions, x equals negative 6 and x equals positive 5. So that's number 2. Let's do number 3 now. So we have x plus 2 over 3 equals x over x minus 2. Okay? And again, I am going to cross multiply. On this diagonal, I'm going to have to do the box method again, because that's going to be x plus 2 times x minus 2. The other diagonal is just going to be 3 times x, so that's 3x. So just like I did on number 2, on that one diagonal, I'm going to have to quickly set up the box method here and multiply x plus 2 times x minus 2. So let's multiply that out real quick and see what we get. X times x is x squared. Negative 2 times x is negative 2x. 2 times x is 2x. And 2 times negative 2 is going to be negative 4. And if I put that together, I'm going to end up with x squared. And then this diagonal is negative 2x and positive 2x. That's going to combine to 0x, right? X squared plus 0x. And then minus 4 equals 3x. So I have x squared plus 0x minus 4 equals 3x. Okay? Now, because this is a quadratic, I once again, just like in number 2, have to rewrite this so that it says equals 0 at the end. So I need to subtract 3x in order to get 3x minus 3x, which equals 0. But if I do that to one side, I have to do the same thing to the other side. So I'm going to subtract 3x on the left-hand side, but I'm going to line it up over here. I'm going to line it up under its like term. So this gives me x squared. 0 minus 3x is minus 3x minus 4 equals 0. So x squared minus 3x minus 4 equals 0. I'm once again going to try and factor. And if I can't, I will go ahead and do the quadratic formula. But this one looks like it's factorable. So once again, I need two numbers that when I add them, I get negative 3. And when I multiply those same two numbers, I get negative 4. So two numbers that when I add them together, I get negative 3. And when I multiply those same two numbers, I get negative 4. Well, those two numbers are going to be negative 4 and positive 1. Okay? Negative 4 plus 1 is equal to negative 3. And negative 4 times 1 is equal to negative 4. So my factored form is going to be x minus 4, x plus 1 equals 0. I can now go ahead and set each factor equal to 0, just like I did in number 2. So my first factor, x minus 4, my answer is going to be x equals positive 4 if I add 4 to both sides. And my second answer, x plus 1 equals 0. So my answer is going to be x equals negative 1. So just like number 2, number 3 also has two solutions, x equals positive 4 and x equals negative 1.